We all know that our bodies need oxygen in order to live and for our cells to survive and function. But what if I told you that breathing short periods of low oxygen, much lower than the air that we're normally breathing, could actually help your body and could improve your health? You can think of this kind of like going to the gym. If you were to go to the gym and give yourself a big challenge, like lifting a big weight for a really long time, you're going to get hurt. And similarly, if we take away all of your oxygen and we do it for a long time, your body's going to get hurt and it won't be able to survive. But if you were to go to the gym and lift light weights and do a lot of repetitions, your body's actually going to get stronger. And similarly, if we give you a small challenge of oxygen by taking away about half of the oxygen that you're normally breathing, and we do this over and over again, your body will get stronger. It'll build up a resistance and it'll be able to tolerate this much better. And we think that this strengthening could actually provide a really important therapy for people. Scientists are calling this acute intermittent hypoxia, and that means that we're taking away oxygen repeatedly to help people. We think that this could be really beneficial, especially for people with diseases and injury. For example, after this therapy, people with spinal cord injury can walk better, they can breathe better, and they get stronger. And we think that all of these benefits happen because the communication throughout the body is improved. And if communication is improved, we think that brain health can increase too. But there's a lot of things that we still don't know about how low oxygen impacts the brain, especially how it could help brain health. And that's where my research comes in. My name is Hannah Johnson. I'm a PhD candidate in biomedical engineering here at Northwestern. And my research focuses on using MRI technology to look at the brain before, during, and after low oxygen in order to understand how the brain can respond to this low oxygen in both helpful and harmful ways. So in order to actually study low oxygen, though, we need to give people low oxygen. And when you're thinking of low oxygen, you might be thinking about just holding your breath. This therapy is a little bit different, though. Instead of just holding your breath, which increases the amount of carbon dioxide while decreasing the amount of oxygen, we are doing something more like taking you up to a mountaintop. Holding your breath becomes uncomfortable because you're increasing the amount of carbon dioxide. But if we keep the amount of oxygen lower, but we keep the amount of carbon dioxide the same, then it's going to be a little bit more comfortable for you. We can't take you up to a mountain in Colorado or at high altitude and then bring you right back down, though, immediately. So we have to do something a little different, and we use a mask and a machine called an altitude generator in order to actually give you low oxygen. And in order to look at your brain, we use an MRI machine. Now, depending on the way that we run the MRI machine, we can look at a couple of different things. We can look at your brain activity, see what areas of your brain are active and how active they are when you're doing a task like thinking. And we can also look at the blood flow to your brain and see how this changes with time or maybe with different conditions. And so these are the two things that we're mostly interested in when we're looking at low oxygen. So in order to look at the long-term impacts, how this could help you in a prolonged period, we go ahead and bring people in for a first MRI. In this MRI, we get a baseline understanding of their brain activity and their blood flow. And then we have them do low oxygen therapy. This could be for one day, it could be for a couple days, it could even be for a couple of weeks. But after they've finished this low oxygen therapy, we bring them back for another MRI. And in this second, we can get another understanding of brain activity and blood flow and compare to the first to see what has changed. We expect the benefits of this therapy to take a while to show up, though. And so we want to get an idea of what could be happening and get an early predictor of this. And we also want to make sure that we're being safe when we're giving people low oxygen. So we also look at the immediate effects of low oxygen therapy. And we do that by giving people an MRI and giving them this low oxygen therapy while they're in the machine. So what are we expecting to happen when they are getting low oxygen? Well, primarily, we're expecting changes in blood flow. When we're breathing normal air, our blood vessels are bringing a certain amount of blood, and therefore oxygen and nutrients, to our brain cells in order for them to continue to function. When we start breathing low oxygen air, though, there's less oxygen for our blood cells to carry, and so we need more blood carrying oxygen to actually go to our brain. And to accomplish this, our blood cells actually expand, or our blood vessels actually expand. Now, you can see this in an MRI image where the image on the right is brighter by a little bit than the one on the left. showing that we are getting increased blood flow to the brain. And how does this increased blood flow help? Well, we think that blood flow will actually increase to the brain in a long-term effect, so that even when you're breathing normal air, your blood flow is higher. We also think that you'll have nutrients and molecules that your brain needs to survive, and we think those will become more available after this therapy. And finally, we think that communication throughout the brain and with the rest of the body will improve with this therapy. And together, all of these things can help us have better memory, better learning, and it could protect against injury like stroke or disease like Alzheimer's or Parkinson's disease, and it could even provide a treatment after things like this have already happened. So this research, though, is still in very early stages. While we think that it could have these exciting benefits, we don't know. It's still very exploratory. Preliminary results from our lab have shown that this is a very safe therapy, and in healthy people, they've had no side effects. But healthy people also aren't as sensitive to this therapy, and they reach a sort of ceiling effect. So we need to understand better what kinds of people can benefit from this therapy and actually have those beneficial effects. It could help people with Parkinson's disease, Alzheimer's disease, these kinds of aging. It could even help with mood and emotional disorders. But we don't really know exactly who can benefit. And we also don't really know exactly which benefits we can expect. We think that all of these things will improve, but what results will that actually have? So while this is a very exciting therapy, and it could be very beneficial for brain health, there's still a lot that we don't know. Thank you.